Hi, this is the first of 2 videos about algebraic thinking. There's 5 main areas of algebraic thinking that we want to talk about and consider how we can help kids learn in these areas. The first is generalization, also meaningful use of symbols, the structure of the number system, patterns in functions, and lastly mathematical modeling. All 5 areas, important aspects of algebraic thinking to implement throughout the elementary school levels. First one, generalization. What is this all about? This is taking ideas from a specific situation and thinking about them more generally, more broadly. We can help kids think about general ideas by asking some good questions like, can you find a rule for something? Why do you know this works? When is it going to be true? Let's take a look at an example and see how these can promote generalization. For example, let's say I start with a triangle, and step 1, I have one triangle here. What I'm going to do at each step is I'm going to draw the midpoints of all the triangles and connect them. So now, at step 2, I have 4 triangles. And if I go to step 3, I would draw all the midpoints of these and connect all of them. And we could count up how many triangles we have there, and we could go to step 4 and step 5, etc. Asking questions like, can you find a rule that will tell me how many triangles there will be at any given step, is a good way to promote kids to think about the general idea underlying these triangles rather than the specific directions of connecting midpoints. What's the general rule? Or, why do you know your rule works? Understanding those ideas helps them think beyond the specific scenario to the general ideas underlying it. Or, when will your rule be true? Will it be true for all steps or just some? Those are important ideas for kids to wrestle with. And the main idea here is they can take these ideas and use them in other situations as they need. So generalization, a very important part of algebraic thinking. Meaningful use of symbols is also another important part of algebraic thinking, and there's really 2 types of symbols that we focus a lot on in algebraic thinking, the equal sign and also variables. Unfortunately, a lot of kids walk away from school with a misunderstanding of the equal sign. They think it means do this. So for example, if I have 4 plus 3 and I put equals down, they think the equal means do 4 plus 3, and in fact the software here even thinks that when I hit spacebar it does it. 4 plus 3 is 7. But the equal sign really means the same as. So 4 plus 3 is 7 is equal because 4 plus 3 is the same as 7, but I could have other things there as well, like I could have, for example, 2 plus 5. And that would be a perfectly valid mathematical sentence because 4 plus 3 is the same as 2 plus 5. And so really a great way to help kids understand the equal sign is to teach them that it works like a balance. Down below here I've got a picture of a balance, an old-fashioned 2-pan balance, and if I put 4 plus 3 over here, in order for this balance to work out I have to have the same amount over here, for example 2 plus 5. When the balance is even, then we have 2 equal things. And that's a great way to help kids think about the equal sign as a balance. You can also work with them looking at true and false sentences and open sentences. An example of a true sentence, 4 plus 3 equals 6 plus 1, that's true because both sides are the same, versus if I just had 4 plus 3 equals 6, that would be a false sentence because the left side is not the same as the right side. So once again, it pushes them back to that same as idea. Same thing with open sentences. 4 plus x is 7. If this x stands for some number, I could pick different numbers and some of them would be true and some would be false. And how do we judge that? We have to go back to the idea of equals being the same as. The other kind of symbol that we want kids to get familiar with is variables. A lot of them get comfortable with the way we just talked about. I have it same here, a variable acting as a placeholder for a missing number. So 4 plus, here x stands for 3 if I want to have a true sentence. But there's a whole other way to think about variables that's very important for kids to come to understand. They can represent quantities that can vary. So here I have 4 plus x equals w, and now I have a lot of options. I could have x as 2 and then w would be 6, or x as 3 and then w would be 7. Or x as 4 and then w would be 8. And then we can go to generalization and say, what's the pattern you're seeing? What's the rule? As one gets bigger, so does the other. Important ideas.